Hey y'all, it's Sean from MathSwap Tutoring, and today I'm going to talk about combining like terms, one of the most important Algebra 1 topics that there is. I can't state that any more strongly. Let's see, combining like terms. This is very, very important. Very, very important topic because it's very foundational to everything that people will learn, everything that students will learn in algebra. Now, before I go on, remember, if you're actually looking for math tutoring, make sure you visit us at this website right here, our Calendly website that you see here. It's also going to be in the description. And then also, you can join our email list by coming here. And don't forget to subscribe to this YouTube channel. Don't forget to like this video. Don't forget to share this video. All right, now all that groundwork done. Let's talk about combining like terms. Now, first of all, when we talk about terms, what are we talking about? So a term, because I don't want to just assume that you know exactly what is being talked about. So all a term is a single number or a variable or a variable with a coefficient. Now, okay. All right. So, and remember, all a coefficient is a number in front of a variable. Front of a variable. All right. So, for example, two. Two by itself is a term. Okay. Another example of a term is 2x. Keep in mind, whenever you have a number and a variable kind of married up to each other like that, they're being multiplied by each other. Okay. That's multiplication, but we don't have to put the times sign in there. So 2x is 2 times x, but this is also an example of a term. Okay. Or y squared. You got 4 times y squared. That's also an example of a term. All of these are different examples of terms. Even if you had 5xyz, that's another example of a term, one term, okay? All right. Now, if we're talking about like terms, a like term, well, let's say like terms, plural. Like terms are terms that have in common their variables, their variables, as well as the exponents on the variables. Okay. And then let's note this too. Note the coefficients do not have to be the same. Do not have to be the same. All right, here we go. So yeah, so for example, x and 2x are examples of like terms. Why? Because, okay, so again, each of these are separate terms. Each of these has an x, and also the x on each of these terms is to the first power. That's what, because they each have an x and they each have that x to the first power, then they're like terms. Now, note this has no coefficient. This has a coefficient. That part doesn't matter. These can be combined because they are like terms. Now, if you had, for example, x squared and 2x, these these are not like terms because yes, while they, let me write that better. While they both have a x variable, this x is to the second power. This x is to the first power. So these are not like terms and therefore they cannot be combined. Okay. X over 4 and 2x. These are like terms. Now, note that this x over 4 is really the same as 1/4 times x. So it's really the coefficient for this term is 1/4. The coefficient for this is 2. But remember, the coefficients don't matter. As long as you have the variable, the same variable, and that variable is being raised to the same power. Let me do one more of these. So if you have and 2xy and 4x, these are not like terms. Yes, they both have an x. Yes, the x is to the same power, but however, this term, you have to look at the whole term. This whole term has another variable in it as well that this one doesn't have. Now, if this was 4xy, these would be like terms. But because this has an additional variable in it, then that makes those not like terms, okay? All right, so now you can combine like terms. So let's do some erasing here. Make sure that you um pause the video so that you can get whatever notes you need to get. But I want to make sure we have space here. Give me a second. So as I say this, just listen to what I'm saying. So you can combine like terms through addition and subtraction. You have to have like terms to be able to add and subtract um terms. All right. So okay, you can combine like terms through addition and subtraction. Okay. And then you can do so, do so by adding or subtracting the coefficients of the terms. Okay. Um, while keeping the variables and their exponents the same. All right, so this would be probably best explained by me with examples. All right, so let's look at this. So say you have 5x minus 9y plus, no, I didn't mean to say 9y. We'll say 9x. 5x minus 9x plus 2x. All right, so first of all, what like terms do we have here? All three of these are like terms. 5x, 9x, and 2x. They're all like terms because they have the same variable and the variables raised to the same power. There are no additional variables. So we're going to combine these by you looking at our operation and in this case, we're going to subtract these two by adding or by subtracting the coefficient. So you have 5x minus 9x. So that's going to be 5 minus 9. That's going to be negative 4x. Remember that the variable stays there. Okay. So let's bring this other piece down that we didn't do anything with, that plus 2x there. Now we can combine these two. So negative 4x plus 2x becomes negative 2x. All right. Easy enough. Very good. All right. So what about this one? A little bit more to it, but it's not bad. Okay. Let me write it down and then we'll go through it. All right. So you have 6 times x plus 5 minus 2 times x plus 5 plus 4 times x plus 5. Now, before we kind of evaluate for like terms, we need to go ahead and combine all of this. So we're going to use the distributive property for each of these little groups here. So you're going to have 6 times this stuff. So that's 6x plus 30. And then we're going to multiply, do the distributive property here. So that's going to be negative 2 times x. So minus 2x, negative 2 times 5 is a minus 10. Then distributive here, plus 4x, and then times here, plus 20. All right, so let's identify our like terms here. So 6x, negative 2x, and 4x are like terms. And then 30, negative 10, and 20 are like terms. So we're going to combine those that way. All right, here we go. So positive 6x minus 2x, that's going to give you a positive 4x, and then plus another 4x is going to be 8x. So I'm kind of skipping steps here, so make sure you follow what I'm saying. Now you have a positive 30 minus 10 is going to give you 20, and then plus 20 more is going to give you 40, a positive 40. All right, so there you go. We've combined those like terms. Hopefully that's pretty straightforward. All right, very good. Now, let's do one more example of combining like terms that's a little bit more complex so you can kind of see in a little greater detail how this stuff works and avoid mistakes in the future. Again, practice is paramount with math because it's kind of like building muscle. You want to keep on getting reps in. All right, here we go. All right, so let's do 5x cubed minus 4x plus 8 minus x cubed minus 3x squared. All right, now, this looks complicated perhaps depending on your experience with algebra, but it's not. It's not at all. The first thing you want to do is, so we have this here minus this binomial here. Let's go ahead and distribute that negative into here. And then let's evaluate to kind of see what like terms we have. So you got 5x cubed minus 4x plus 8. Now we're going to do a minus. Remember, that's like a -1 times each term. So that's going to be minus x cubed. -1 times this is going to be plus 3x squared. Now let's look for our like terms. Are there any other x cubed terms? Yes, you got this one and this one. All right, what about x terms? You got this 4x term, or are there any other x terms? No. What about constants by themselves? No. What about x squared terms? No. So the only like terms are these two right here. So those are the only two we have to combine. So 5x cubed in a negative x cubed, that'll be 4x cubed. And let's bring everything together. And I'm going to write it in order of descending exponents. You don't have to, but it's a good practice to do so. So it's going to be plus 3x squared minus 4x plus 8. Final answer. All right. Now, also important to note, whenever you are combining like terms, when it comes to multiplication and division of terms, you don't have to have like terms in that case. You don't. All you do is multiply, divide the constants, and then observe the exponent rules to multiply and divide variables of the same type. Now, so let me write some of that down. So you do not have to have like terms to multiply or divide terms. All right. So let's do an example. So you got 5x to the 5th power times 3x squared. Now, these are being multiplied by each other. Are they like terms? No, because you have the same variable but different exponents on the variable. But it doesn't matter. So all you do is you multiply the constants by each other. So that's going to be 5 times 3 is, let me do it this way. So you can also rewrite this as 5 times 3 and then times x to the 5th times x squared. Okay, so this is the exact same thing. We just kind of grouped it according to the constants and the coefficients and the variables. So because that's how you combine you multiply the numbers by each other, and then you multiply the variables by each other. So 5 times 3 is just going to give you 15. And then you have x to the 5th times x squared. That is going to give you x to the 7th. Because if you remember, when you have two values being multiplied by each other, the same base numbers, but different exponents, is going to be the same as the base number with those exponents added to each other. And if you need a refresher on exponent stuff, I try to make sure I tag my video that talks about exponent rules and whatnot. All right, so let's do another example. Let's say you have 4x squared y to the fifth power times negative 2xy cubed times negative 3xy. All right, don't let this be intimidating to you. I know it's a lot of numbers and variables and stuff like that, but it's not bad at all. Just do this exact same thing we did before. Do the multiplication on those constants, those coefficients first, then multiply the variables times each other, of course, according to the same variables or whatever. Make sure you multiply the variables of the same type times each other first. So you can break it up like this, and I'll do that again for this example. But you'll get to the point where you don't have to do that anymore. So you got 4 times negative 2, which is negative 8. And then a negative 8 times negative 3 is a positive 24. Then you got x squared times an x term here times another x. And then you're going to have y to the fifth times y cubed. So y to the fifth times y cubed times y. Okay, so that's going to be 24 times x squared times x to the first. So you add those exponents, that's x cubed, and then add another x. So it's going to be x to the fourth. Okay, I didn't need to write those parentheses there, but oh well. I'll just be consistent. And then y to the fifth times y cubed, that's going to be the 5 plus 3, so that's y to the eighth. And then another one's going to be y to the ninth. Okay, and that's your final answer. Again, with the final answer, you really don't need those parentheses. Just leave those out of there. Hopefully. All right. All right. Now let's do one more example here. And then we will call it a day. So you got negative 8a cubed b to the fifth times 2a squared minus 7ab squared minus 3. All right, so again, don't be intimidated by all the numbers and all the variables and stuff like that. It's all the same thing. The most important thing for you to do is take your time. That's the most important thing. Now, so again, this is not really in like a simplified form. So you want to go ahead and distribute. So you're going to multiply this outside of the parentheses by each of these three terms. This one, and then this one, and then this one. And remember to pay attention to your signs. All right, so this becomes, so this times the first term, you're going to have that negative 8 times 2, which is negative 16. And then a cubed times a squared is a to the fifth. And then b fifth, there is no other b there, so that just stays b to the fifth. Now we're going to multiply this times the next term. So that's going to be negative 8 times negative 7, which is a positive 56. A cubed times a is a to the fourth. B to the fifth times b squared is b to the seventh. Okay. Now, and then the last term, negative 8 times negative 3 is a positive 24. And there are no variables in this term. So we can just kind of bring those over because it's they're not going to change. A cubed b to the fifth. So the most important thing, which is probably like the main way that people make mistakes, is keeping track of your negatives. And also making sure that you add those exponents properly. Again, make sure that you watch the exponent rules video that I have to refresh your memory on the way the exponent stuff works. And yeah, get this, watch it as many times as you need to, so that you get it. Okay, make sure that you get it because this is so foundational to algebra and really all the math that you'll ever do. No matter how much math you end up taking, in the future. All right, make sure again that if you need tutoring, that you use the link to sign up for a free consultation. You can join our email list, and don't forget to subscribe to this YouTube channel, like this video, and share this video, guys. All right, thank you, and stay tuned for the next videos. All right.